All righty, so I'm gonna go into math lab. So this first one, they want us to graph that. So I've taught y'all the calculator pretty good. So all we got to do is match it to one of these graphs here. So let me go in and grab my TI calculator. And then I'm already on y equals. And I'm just going to put that equation, which was y equals what? 1/6 to the x. So I'm going to do parentheses. 1 divided by 6. Close parentheses. And then my exponent was an x. So all we got to do is graph that, y'all. See what it looks like. So hit graph. Whoops, ooh, mine's shading. So let me go back to my y equals. Let me turn that shading off by going all the way left and hitting enter. So I don't want mine to shade, so I'm going to tell it. Let me change that line. Oh, I think I was on it the first time. That looks like a line, right? So let me try that. Oh, I didn't save it. Okay, going back. Oh, I didn't hit OK. Let me go down, hit OK. All right, now, so when I hit graph, you can see it's just a line now. So it looks like it's going downhill to the right. So let me go to math lab. Downhill to the right looks like A. So y'all just click A and then hit next. All right, so this is the main number 2 and number 3 are the main ones I wanted to show you online. And then I'm going to start working them by hand on paper. So this one, our base is a 2. So we're going to start with the graph of y equals 2 to the x. And they've already got the x in the blank. So we got to figure out what that plus 2 is doing. So anytime you attack the x when it's an exponent, that's going to move me left or right. So since that's a plus 2, it moves opposite what you think. And that's actually going to move me 2 units to the left. So we need to find one that says 2 units to the left, which would be C. And down here in the box, put your 2. All right. And when you do that, you want to click to enlarge the graph. All right. So the exponential graphs are the fifth option down here. It looks like a little curve going to the right up to the right. So I'm going to click on it and then just click it anywhere on the graph and it'll put the line and pops open the box. So since mine went 2 units to the left, I'm going to come down here first and change the base. So let me change my base to a 2. So make sure you change your base to what you got in your problem, okay? So the base is the number in front of the exponent. Then go up to your horizontal shift, and I went left 2, so hold that down until you get to -2. And then y'all at that point, just save it, and it moves the graph for us. And then we click next. So the next one's going to be doing the same thing, but it's got 2 moves on it. So start with the graph of y equals, well, my base is a 2 again. So in that first box, put your base, which is a 2. Notice they've already got the exponent x there. So now they're talking about the 5. So the 5 is up here on the exponent again. Same thing as while ago. Since that's a positive 5, it's going to move me left. So pop the arrow, go to left. And then at the end, there's a -1. So when it's at the end like that, it's up or down. So since that's negative, it will go down. So that one moves how you think. Just remember when you attack the exponent, it's opposite what you think. All right, so we got to click the enlarge graph, click the little tool, the exponential tool, click anywhere on your graph. All right, so first thing, go down here to the base and put in, for me, it's a 2 again. I had a horizontal shift, went left 5 units. So I'm going to shake that to a -5. My vertical shift, we went down 1. So I'm going to take my vertical and take it to a -1. So doing that moves the graph for us. Save that. And then I'm going to start working them on hand after this. So let me go to my paper now. All right, so I'm going to start with number 4. Now, y'all, let me tell you this also. I got 30 questions on the study guide you got to do. Remember, that's a quiz grade. But I made the test 5 questions shorter. So this number 4, we're going to work it because it's on your study guide, but I took number 4 off my test because it was sort of long. So on number 4, they said we had $61,000 invested at 6.5% interest, compounded quarterly. So for part A, they want me to find a function for the amount to which the investment grows after T years. So they basically just want a formula. So the formula for the interest was A of T equaled P times parentheses 1 plus R divided by N, all to the exponent N times T. So since they want it to be a function of time, the T variable will be there. We need to fill in for everything else, the P, the R, and both the N's. So P is my principal, which is 61,000. I was going to say, if y'all ever had a class called mathematical reasoning, y'all should have seen these formulas in that class. I know Cameron did because I had her in my math reasoning class. All right, y'all, here we go. 1 plus R is my interest rate. So that's 6.5. So in decimal form, that would be 6.5%. But remember, you got to turn percent into a decimal to put it into the formula. So move the decimal left twice, which means I need to add a 0 and make that a 0.065. So R is a 0.065 divided by N. So y'all, how many times a year would be quarterly? Y'all remember that? All right, let me hit the chat. It's popping up. All right, so y'all are saying 4, good job. So 4 times is quarterly. And then my exponent is N times T, which would be my 4, and then my T. Now, that's the right formula, but for Math Lab, they want us to simplify the stuff inside the parentheses. So bring down your 61,000. All right, so I'm just going to figure out what that equals. So that is, right calculator, come on. 1 plus 0.065 divided by 4. That part's going to give me 1.01625. And then my exponent is 4t. Y'all, this is what Math Lab wants you to put in. They're already going to have the A of t there, so just put in our formula. All right, so then part B, find the amount of money in the account at t equals 0, t equals 4, t equals 8, and t equals 10. So here we go when t equals 0. So we're going to use the formula. Now, by hand, you would put a 0 in for that t, punch that in and see what it gives you. But I showed y'all how to use that value function on the calculator. So I'm going to work them like that because it's pretty quick. So go to y equals. All right, let me clear that out. So when y equals, I'm going to put our equation we had, which was 61,000, parentheses, 1.01625, close parentheses, and then my exponent is 4t, but when we graph it, we're going to use x's, okay? So that'll be 4x. So no matter what the variable is here, to graph it on the calculator, you got to use x's, okay? So I'm not even worried about the graph. What I'm worried about is finding values when I give it my values for those t's or x's. So to do that, you hit second, trace. Value is the first thing you see highlighted, so hit enter. Now in a second, you'll see it pop up at x equals down here. So there it says x equals. My first is going to be 0. So when I hit enter for 0, on the right side is my y value, which is saying 61,000. So when t is 0, makes sense. No years passed. You better have your money you started with, which was 61,000. So now I would do t equals 4. So I would hit second, trace, enter for value. This time I'm going to do a 4 and hit enter. And this one's wanting you to round to the nearest dollar. So this is giving me 78,947.57. So since that's a 0.5, I'm going to round that 7 to an 8 and make that 78,948. And guess what? Since it's an investment, these amounts better be going up over time, right? All right, y'all, when t equals 8, I hit second, trace, enter for value. Now put in an 8 and enter. So it's giving me 102,175.7. So since that's a 7, I'm going to round that 5 to a 6. So I got 102,176. And then finally, second, trace, enter for value. This time we had t equals 10. Enter. So this one's 116,239.08. So I'm going to leave that a 9. So I got 116,239. So your money definitely went up over time. And after just 10 years, your 61,000 almost doubled. All right, so that was that one. So remember, I took it off the test because I thought it was sort of long. But I did keep using that formula for the next one. On the next one, on Melissa's 6th birthday. So on her 6th birthday, she got a $3,000 CD that earns 7% interest, compounded quarterly. If the CD matures on her 13th birthday, how much money will be available? So y'all, it's going to be the same formula we used up here. A of T will equal P, which is her principal. We also starting with $3,000. Then we got 1 plus R is 7%. So what would y'all put that in as a decimal? All right, so 0.07, good job. So that's 0.07. Y'all told me quarterly was what, 4 a while ago? And then that'll be 4 times my time. So what would y'all put for time?
7.
7 years. Good job. Because her 13th birthday, got it on her 6th. So that would be 7. All right, so let's push that in. And this one, they want me to round to the nearest cents. So I'm going to clear off of this. So here we go. 3,000 parentheses 1 plus 0.07 divided by 4. Close parentheses, arrow up. So 4 times 7, or you could just put what, 28 there. All right, y'all. So round to the nearest cents. 4,876.2. So my 3 has an 8 after it, so we'll make that a 4. So we got 4,876.24. So I guess she almost made 2,000 off her 3,000. Well, she waits a few more years, she might even be able to get what, a used car, right? All right, y'all. Find the logarithm. I got log base 10 of 10. So what y'all think that equals? Oh, y'all slept over the weekend and done forgot my logs. So check this out. What exponent would I raise this 10 base to turn it into a 10? Perfect. That is a 1. Anytime that base matches, remember, anytime our base matches, it's got to be 1 on that, okay? All right, find the next logarithm. Log base 2 of 2 to the 4th. Now, y'all, if I was doing these on my calculator, I would use the log base feature that's in the math. So hit math and arrow down. So let me show you. Hit the math button, arrow down till you find log base. When you find log base, hit enter. So you got a 2 for your base. So put in a 2, arrow right. Well, I keep having to put people right back in. Arrow right, and then that's 2 to the 4th. So 2 exponent 4. So now when I arrow out of that thing, it looks just like what they got. But y'all check this out. Anytime the base matches that base to an exponent, watch what you get. You get that exponent. Because remember, the power rule says I can write this by bringing the 4 down, and I would have 4 times log of base 2 of 2. Well, remember, this log base 2 of 2 is 1, because y'all just proved that up here, and 1 times 4 gives you 4. All righty, y'all. Y'all fun on the chat sometimes. All righty, y'all. So number 8, log base 25 of a 5. So I'd probably use log base on that and also. Hey, you actually got that right on there, but now turn that 0.5 into a fraction, because MathLab wants us to put a fraction in there. So if you get that answer, just hit math and enter twice, because it'll give you a fraction. And so that 0.5 would give me what, a 1/2. So y'all remember MathLab, there you go. You got to get me a 1/2 on MathLab, okay? All right, 9 log base 26 of 1. Oh, perfect. That's a 0. Perfect. I was about to kick y'all out if y'all missed that. So that is definitely a 0. So anytime that's a 1 there, I don't care what this base is. Good job, Zach. You're going to get a 0. All right, y'all. So next on these next 2 examples, they want me to convert to logarithmic. So they're going to give me an exponential, and I'm going to turn them into logarithmics. So this would be my number 10. I got 10 to the 6 equals 1 million. So you got to turn it into logarithmic. So we need to write log. The base for this log is that 10. The result is the 1 million. And that's going to equal my exponent of a 6. Okay. So remember, when you write this in, you punch in log, it'll make it highlighted. Use the little subscript box to put the 10 in, then arrow back up even with the log and put in 1 million and then equals 6. All right, same thing on 11. They got e to the 4 equals m. Oh, y'all, let me ask you this. On this one, I just got a log base 10 of 1 million. Could you not write that as just a log without the 10? Because remember, if there's not a number there, we assume it is a 10. So that log that's on the front of your calculator is a log base 10 button, okay? All right, so this one, I got e to the 4 equals m. So writing it as a log, I got my log. The base is e. The result is a little m. And that's going to equal the exponent of a 4. Now, this is a special log. Anytime I get a log base e, we rewrite that with the ln of m equals 4. So we use a natural log when we got a log base e, okay? So remember, that is a ln, not an in. All right, the next two on here, they want us to go the other way. We're going to turn logarithmic into exponential. So we're going to convert to exponential. All right, y'all, so I'm starting out on number 12. I got a log base 4 of 64 equals 3. All right, so my base is the 4. The exponent is the 3, because remember, the logarithm finds those exponents. So my exponent is a 3, and that's going to equal that result of a 64. Y'all, guess what? If you punch 4 to the 3rd on the calculator, it will give you that 64. All right, 13, log base n of a capital T equals a negative z. Now, MathLab is picky on lowercase and uppercase letters, okay? So I got a capital T and then 2 lowercase n and z. All right, so my base is the n. My exponent is the negative z, and that's going to equal that result of a capital T. So on that one, I ain't going to lie, they just threw all those letters at you to see if you would remember where they went, okay? All right, y'all, so this page wasn't too bad. It's just a lot of understanding what a log was, okay? All righty, on 14, they want me to use a calculator to find the natural log. And we're going to round this out 4 decimal places. So for 14, they want me to find ln of 449.9. So y'all, we just punch that on the calculator. We got an ln right on the front. Put in our 449.9. Hit enter, and I get 6.109. So 0 is where I'm rounding to, That's a 2 after it, so I want to leave that at 0. So that'll be 1090. Okay. Now this one says, on 15 says, find the log using the change of base formula. That's using that log base on your calculator. So they want to know what is the log base 2 of 18. And we're going to round this one 4 decimal places. All right, so hey, oh, you got that right. I didn't even see that chat. So how about that one? Log base 2 of 18. So that one, you got to hit the math button and go down and get that log base. Hit enter on that. What you're gonna put in your 2, then arrow right. So let's see. I need to get what, a 4.1699. So let me put in my 18 and enter. Oh, perfect. So you left that a 9 on. I mean, y'all left that a 9 there because that was a 2 after it. So that is 4.1699. Good job. All right, y'all. So the next few ain't really calculator problems. They're going back over the 9-6 stuff where we had to rewrite the logs. So this one's saying express as a sum of logs. So they're giving me log base 18 of 18 times 324. So they don't want me to evaluate this. They just want me to rewrite it as a sum. And that's what you do when they're being multiplied. You rewrite them as addition. So this would be a log base 18 of 18, the first factor, plus log base 18 of 324. So basically, you're sort of distributing that log to them, okay? All right, y'all, that's what MATLAB wants. So then you go to 17. 17 wants me to express as a product. And this one's really one of my favorite rules because it's the one that lets me solve for those exponents on the equations. So for this one, they're giving us a log base 10 of z to the 11. So to express this as a product, this is the one where we took the exponents and brought them down to the front and wrote it as multiplication. So that would be 11 times log base 10 of a z. So that's why we, on some of them equations, I have to take the log so I can get them exponents brought down. So I'll show you when we're doing them what I'm talking about. All right, I think I can fit one more on here. 18, rewrite as sums or differences. Well, here's the thing. If they're being multiplied, they'll be sums. If they're being divided, they'll be differences. So let's see what they're giving me. They're giving me an ln of parentheses, x to the 6th, y to the 5th, and a z. So y'all check this out. Since all three of these are being multiplied together, it's only going to be sums on this. There's only differences if you got division. So distribute the ln to all three of these factors. You'll have an ln of x to the 6th, plus an ln of y to the 5th, plus an ln of z. So y'all, let me ask you this. Am I done?
No.
No, so what do you got to do to that? Move the exponent to the front. Perfect. So two of these got exponents. So remember, we got to move the exponents to the front using that product rule so that we get a 6 ln of x plus a 5 ln of y plus a ln of our z. Now, y'all, so although it didn't say nothing about products, we got to automatically bring those down to simplify this, okay? All right, moving on to the big boy here, number 19. Express in terms of sums or differences of logs. So they're giving me log base b of p to the 4th, q to the 5th, all over m to the 4th, b to the 7th. All right, this one's on your review, but I took this one off the test because it was a really long problem. But it's not too bad. So the stuff on top will be rewritten as addition. The stuff on bottom, those two factors, will be rewritten as subtraction. So here we go. Distribute the log base b to all 4 factors. So log base b of p to the 4th plus log base b of q to the 5th. So those two factors on top are positive. Now we start subtracting the log base b of m to the 4th minus the log base b of b to the 7th. All right, next move. Move those exponents. All righty, so bring the 4 down, the 5 down, the 4 down, and the 7 down. So you get a 4 log b of p plus a 5 log b of q minus a 4 log b of m minus a 7 log b of b. So can I go any further? Or can I simplify any more? Oh, I got y'all finally, looks like. Oh, y'all gonna let me get you, ain't you? All right, so I'm gonna circle one part on here and you tell me what this part equals. I'm gonna circle the log base b of a b. What does that part equal? Perfect, that equals 1. So since that equals 1, that's going to give us a -7 there. So good job. So our last final answer would be 4 log b of p plus 5 log b of q minus 4 log b of m minus 7. Good job. So see, that would add a lot of work to it. So I figured, well, I'll let y'all do it on your quiz, but I took that one off. So that was the second one I took off. All right, so let's see. 20 and 21 want us to simplify. So for 20, we're going to simplify ln of x squared plus 15x plus 56 minus the ln of x plus 8. So first, I'm going to write this as a single logarithm. Since they're being subtracted, we'll rewrite it as division. So that's going to be ln. The top will be x squared plus 15x plus 56. We'll be dividing that by x plus 8. So if this is going to simplify any further, we're going to have to factor the top to see if we can get a factor like an x plus 8. If we get an x plus 8 on top, we'll cancel them out. So we know the top's going to factor into parentheses. So I'm going to factor by hand, but what you could do is punch 1, 15, 56 on your calculator using quad. Quad will give you the 2 answers. So what you do to put it in factor form, change the sign of them answers and put it in factors. So I'm gonna factor by hand and then I'll tell you what quad would have done. So x squared is an x and an x. Last sign's positive, so both factors will be positive like a middle number. Factors of 56, that'll add to give me 15. Well, they got an 8 down here, so I'm going to think, what is that, 8 times 7? So that's going to be an 8 and a 7. So if you punch in 1, 15, 56, quad would have gave you a -7 and -8 for the answers. But remember, in factor form, you change those signs, okay? All right, y'all, so bring down the LN. X plus 8's cancel. So since we got one binomial factor left, you got to keep it in parentheses. If you don't keep it in the parentheses, the calculator will think it's the ln of x plus 7. It won't be doing the ln of the x plus 7 added, okay? Right, 21, express as a single log and simplify. So this one they're giving me the log of x squared minus 2x minus 35 minus the log of an x squared minus 25. So once again, they're being subtracted, so we're going to write it as division. So we got log, top will be the x squared minus 2x minus 35. The bottom will be the x squared minus 25. So if it's going to simplify, we got to factor the top and bottom and see if any factors cancel. So on quad, you would do 1, -2, -35. It's going to give you 2 answers. Change the signs when you put them into factors. The bottom, you would use 1, 0, -25 on quad. It'll give you 2 answers. Change the signs when you put it in here. Y'all watch this. X squared is an x and an x. Last sign's negative, so we got unlike signs no matter what. Since the middle is negative, my larger number will be negative. So factors of 35, that'll subtract and give me 2 are 7 and 5. The 7 will be negative. 5 will be positive. Those equal -2 when you add them. The bottom, that's perfect squares. So that's an x and an x. That's negative. So you got 1 positive, 1 negative. Perfect squares, all you do is take the square root of 25 and that'll give you the 2 numbers. Square root of 25 is 5. So that'd be a +5 and a -5. So y'all, what's going to happen? X plus 5's canceled out. So our final answer will be log x minus 7 divided by x minus 5. Now, since this one was left as a fraction, I technically don't have to put those parentheses around those, okay? Because it knows that this part's the numerator and it knows that this part's its denominator. All right, y'all, let me see what's coming up. Looks like we got some solving coming up. So 22 says solve for x. They're giving me 6 to the 8x equals 216. So the first thing on these equations when they're exponential is you want to see if you can rewrite each side using the same base. So since this side's got a base of 6, I need to see if I can rewrite 216 using a 6. So watch what I'm going to do. Since the base is 6, I'm going to multiply 6 times 6 and hit enter. That gives me 36 times 6 again. Oh, y'all look at that. That gave me 216. So I did what? 1, 2, 3 6s, which means I can rewrite 216 as 6 to the 3rd power. Over here, I had 6 to the 8x. Now, we did good because we got those bases to match. Since these bases match, that means the exponents have to be equal to each other. So 8x has to equal that 3. Y'all, one more movement, we're done. What y'all doing to that?
Turn into a fraction, 3/8.
Yeah, so you just divided both sides by 8. Good job. So those 8's cancel. Couldn't do nothing to that 3/8. So let's just leave that 3/8. And if you remember in the homework, you had one that you usually could rewrite the base for, and then you had one you couldn't rewrite the base for. So this one, my exponential is 3x equals 2. Well, watch this. If you try to multiply 2 times 2 on the calculator, you get 4. So you cannot use a 2 to rewrite a 3 with, or you can't turn a 3 into a 2. So that's not happening on this one. So what I need to do is bring that x down. So to bring the x down, I take the log of both sides. So since I took the log of both sides, I can now take that exponent and shoot it down to the front. So I get an x log 3 equals my log 2. Oh, you're sort of close. So to solve this, you want to divide both sides by the log 3. So the log 3's will cancel over there. And then do your log 2 divided by log 3. Now, when you do this on the calculator, though, you got to remember, put them in parentheses, and you can't cancel out the logs and make that 2/3, okay? So you got to do the log of 2, close parentheses, divided by the log of 3, close parentheses. And the ones where you got to write them as a with the logs, those ones you're going to have to estimate the 4 decimal places. So on this one, we got 0.6309. After the 9's a 2. So I'm going to leave that at 9. So I got x equals, because those logs canceled, 0.6309. Right, 24, solve for t. They're giving me e to the negative 0.0. Whoops. Let me start that over. E to the negative 0.66 t is going to equal 0.03. So I'm not going to try to rewrite that 0.03 using the base e. That'd probably be impossible. So I need to bring that exponent down. So since this is a base e, I'm going to take the ln of both sides. Ln of e to the negative 0.66 t will equal to ln of a 0.03. All right, so now we would bring the power rule down. So you get negative 0.66 t. Somebody figure out what does the ln of e part equal. Because remember, this is really, ln is really a log base e. So this will be a log base e of e. That's what I'm about to write here, but what does that equal? Because I might not even have to write that, right? So let me ask this calculator. I got an ln button on it right here. So ln, there's a little bitty e above the division. So hit second divide. And y'all watch this. Ln of e equals 1. So that's like negative 0.66 t times 1, which is just negative 0.66 t. So anytime you got an e and you take the ln of it, all it's going to equal in the long run is whatever that exponent is. All right, the right side is ln of 0.03. Okay. All right, so now divide both sides by negative 0.66 and we'll have our t together. So that's 0.03 divided by negative 0.66. All right, so that's going to give me 4 decimal places. So here we go. We got ln 0.03, close parentheses, and divide that by the negative 0.66. That gives me, let's see what's happening, 0.3129. Woo, that's a 6 after the 9. So I'm going to round that 9 to a 0, which means a 2 becomes a 3. So I get 5.3130. And y'all, that was taken off the test, but it is on your quiz, okay? All right, y'all, 25. Solve. I got 21 to the x equals 7 to the x plus 1. So you cannot rewrite them using the same base. So I'm going to take the log of both sides to get these exponents down. So log of 21 to the x equals log of 7 to the x plus 1. So now we can bring our exponents down since we did the log. So I get an x log 21 equals x plus 1 times my log 7. So I'm putting that in parentheses because this whole exponent has to be multiplied by that log. All right, y'all, next step, distribute the log 7 to both of these parts. Get rid of parentheses. So x log 21 equals x times log 7 plus 1 times log 7, which will just be a log 7. All right, we're solving this for x. I got an x here, and I got an x on this side. So I need to bring this x to the other side by subtraction. Now, these are not like terms, so you're going to have an x log 21 minus x log 7 equals log 7. But we're happy we got the x's on the same side. Now, since these are not like terms, I need to factor that x out like a GCF so that you get x times parentheses log 21 minus log 7 all equal to your log 7. So remember, anytime that x is in 2 different terms, the only way to turn it into a single x is to factor it out like a GCF. All right, y'all, last step is to divide both sides by these parentheses. Log 21 minus log 7. Divide this side by log 21 minus log 7. That stuff cancels. All that's left is my x. So here's the thing on this one. You got to close all the little parentheses around these logs. But the bottom has to be put in extra parentheses because it's got more than one part. So on my calculator, I would do the log of the 7 on top, close parentheses, divided by parentheses, log 21, close those parentheses, minus log 7, close those parentheses, and then close the denominator parentheses. We're going to round this 4 decimal places. So it looks like we get a 1.7712. So since that's a 4 after the 2, I'm going to leave that a 2. Guess what? I took that one off the test. I thought that was a little difficult doing all that GCF stuff. So 24 and 25, or the other 2 I took off. All right, y'all. So what's that lead me? 26. 26 says solve for x. So log base 2 of 2x minus 3 equals 4. So anytime we got a single log on one side equal to a number, I rewrite it as exponential. So my base is 2. My exponent's to 4. That's going to equal that result of a 2x minus 3. All right, y'all. 2 times 2 times 2 times 2 is 16. That's going to equal to 2x minus 3. Y'all, 2 more moves, we're done. We're going to add 3 to both sides. So I get 19 equals 2x. We're going to then divide both sides by 2. So that's going to give me 19 halves equal to my x. All right, 27, same thing. Log base 4 of c plus 21 in parentheses minus log base 4 of c plus 5 is going to equal log base 4 of a c. So that's a log base 4 of a c right there, y'all. All righty. So the first thing you do, since you got 2 logarithms on the left side, rewrite that as a single log. They're being subtracted, so we rewrite them as division. So I get log base 4, c plus 21 over c plus 5. That's going to equal the log base 4 of our c. So guess what? I got a log base 4 on both sides. So since these log bases match, that means this result equals that result. So c plus 21 over c plus 5 is going to equal c. All right, so what you want to do to that? Put you at 1 under the c to make it look like a fraction. Cross multiply. This top multiplies by the other side's bottom. So c plus 21 times 1 is c plus 21. That's going to equal this bottom times the other one's top. So c times c is c squared. C times 5 is a positive 5c. All right, y'all, so guess what? That's quadratic, so I need everything on one side equal to 0. So I'm going to subtract the c from both sides. I'm going to subtract the 21 from both sides. So I get 0 equals c squared plus 5c. Oops, 5 minus 1 left me 4c. So that's a 4c, y'all. And then bring down that minus 21. So y'all, I'm going to get 2 answers for c. So y'all put in a 1 on your quad, a 4, and a negative 21. That should give you a negative 7 and a positive 3. So what's the final answer?
3.
Bam, good job. Cannot keep answers that are negative when you're dealing with logs. Remember, a log of a negative number gives you an error message, okay? All right, y'all, so .28, same thing. I got a log base 3, x plus 4, plus a log base 3 of x minus 4 is going to equal 2. So y'all, we don't have a log on the right side, so we're not going to be able to use that log equals a log. But what we got to do first is turn these 2 logs on the left side into a single log. So we got a log base 3 They're being added, so we rewrite this as a product, x plus 4 times x minus 4, all equal to our 2. So remember, subtraction, you rewrote it as division. Addition, you rewrite as multiplication. All right, so before we rewrite this, let's FOIL that. So we got log base 3. So y'all, this is the difference of perfect squares because these are conjugate pairs. So all you got to do is do x times x, which is x squared. 4 times -4 is a -16, all equal to our 2. You don't have to FOIL the whole thing because the inner and the outer stuff is going to cancel every time on conjugate pairs. All right, now rewrite this as exponential like we did a while ago. So our base is 3, exponent's 2, and that's going to equal x squared minus 16. So we'll figure out what 3 squared is first. So that'd be what, a 9? Equal to our x squared minus 16. So y'all, here we go again. We got that x squared term again. So we need everything on one side equal to 0. So subtract that 9. 0 equals x squared minus 25. On quad, you would use a 1, 0, -25 for your 3 numbers. So quad's going to give you 2 answers, a 5 and a -5. But y'all remember, I got logs up here. So I cannot keep that negative answer, and the only answer would be x equals 5. All right, y'all, man, I think I might even be able to finish this whole thing because I got only 2 to go. So this one's the long one. Actually, the last 2 are longer. So I kept 29 and I marked out 30, but we'll do both of them. So 29 says you got $19,277. You're investing at an interest rate of 5.6% per year, compounded continuously. So for part A, find the exponential function that describes the amount in the account after t years. So y'all, since this is continuously, we use our formula P of t equals P sub O times E to the K T. P is your initial amount. K is your growth rate or interest rate. T is the time in years. So our general formula would be P of O, which is 19,277. E, K, which is my interest rate. It's sort of like the R is in the interest formulas. But remember, that can't be a percent. So 5.6% needs to be turned into a decimal by moving it left twice. So you're going to have to add a 0, and that's going to be 0.056 T. So y'all, that is what Math Lab wants for our formula. All right, B wants to know what's the balance after 1 year, 2 years, 5 years, and 10 years. And these, they want me to round 2 decimal places. So y'all, I'm just going to go back and use the value on my calculator. So go to y equals, we'll clear that out. I'm going to put in this formula we got, 19,277 times E. So second ln gets you the E with the exponent, which is 0.056. And remember, I can't use T, I got to use X in the calculator. All right, so I'm going to hit second trace to go to the value, hit enter. All right, it's going to take it a second, but it's going to ask me X. First X is 1, enter. Remember, I'm rounding 2 decimal places for cents. So I got 20387.31. So that was when t equaled 1. When t equals 2, so I hit second trace for my calculation for value. This time I said 2, enter. So I get 21,561.57. Next was t equals 5. So second trace, enter, put in a 5, enter, 25,505. Point. Looks like what, 973, so I'm gonna leave that a 97. And then y'all finally you would do that after 10 years. Second trace, enter, 10. It looks like 33,747. Point. That's a 714, so I'm gonna leave that a 0.71. And then C, they want to know what's the doubling time. Well, remember the doubling time, capital T, is equal to the ln of 2 divided by your K. So ln of 2, we know our K, we have our K in the formula right here. That was 0.056. So let's put it in. So clear that page. ln of 2, close parentheses, divided by 0.056. Hit enter. They want me to round one decimal place. So I got 12.37. That's going to be a 12.4. And then they'll put the years there for you, okay? All right, so you got to do 29, but since both of those were pretty long, I took off 30. So 30, they give us a table. They got a year. They go from 1960, 1980, 2000, 2010, 2012. And this is the percent of married adults. They got 73.7, 66.6, 56.1, 49.7, and then 46.2. So A, they want me to use the data from 1960 and from 2012 to find the value of K. Well, y'all, I gave you a formula for K. K equals the ln of your PT divided by P initial, all that divided by your time. Well, PT is your ending amount. So the ending amount would be 2012, which would be 46.2. PO is our initial amount, which was 73.7. You notice this is declining, right? So since this is declining, our growth rate should be negative instead of positive. So y'all, here we go. We got ln. Ending amount is 46.2. Initial amount, 73.7. Oh, y'all, I need how many years that is. I need my years. How many years is it from 1960 to 2012? So let's add that up. I know 60 to 2000 is 40. 40 and 10 is 50, and 2 more is what, 52 years? So T is 52 years. So let's push that on and see what we get. All right, y'all, so I got ln 46.3 divided by 73.7. Now close parentheses, because you're doing the ln of that quotient. Then that answer divided by 52. So look, we said it would be negative, and there we go. We get a negative 0.0089. Now, here's the thing with Math Lab. The reason I pulled this question off, our K is negative, but all they want you to put in is the 0.0089 for the K. Sort of weird because then they ask you to put the formula down for this function. M stands for married people, okay? So remember, that would be my P of O, which would be my original amount, 73.7 times E to the negative 0.0089 T. So it's weird. When you put in for the K, it's 0.0089, but when you put it into this formula, you gotta put the negative. I really think they should have let you put the negative in both places, but like I said, in this K, they don't want that negative, okay? Just put in the 0.0089. All right, y'all, then they want you to put this in for the formula part of it. You got to put the negative. All right, part B, they want to know how many people are going to be married in 2015 and 2018. So all you got to do is figure out what that T is. We know 2012 was 52 years. So that'd be 3 years later. So our T would be 55. So let's punch in 73.7. Second LN to get my E. My exponent will be negative 0.0089 times, what I say, 52, 55 years. All right, y'all, let me see. Rounding one decimal place, we're going to make that a 45.2. So in 2015, we predict 45.2% married people. 2018 is 3 more years, so that was 55. So we're going to do it for 58 this time. So 73.7, second LN, negative 0.0089 times 58. So it should be going down because remember, it's declining. So now I got 43.98. So I'm going to round that 9 up, right? To make that a 44.0. Oh no, I'm rounding one decimal place, right? Yeah. Oh God. 44.0. Woo, my brain went dead for a second. All righty. So then C says, part C says, at this decay rate, in which year would the percent of adults who are married be 38%? All right, so 38% would be my ending amount. So I gave you a formula to find time equals the LN of your PT, your ending amount, divided by your PO, your initial amount, all divided by K. So y'all, we got everything we need. LN, PT was the 38%, divided by the beginning amount, which was that 73.7. Take all that and divide by K, which was a negative 0.0089. Now they want to know the years, so this will tell me how many years passed from 1960 to get that mark. So here we go. We're going to do LN 38 divided by 73.7, close parentheses, divide by our K, negative 0.0089. When we do that, we get, let's see, round to the nearest whole number. So I'm going to keep that at 74. So since this is 74 years, we got to take 1960, add our 74 to it, and let's see what that gives us. $20.34. So in the year 2034, we would predict around 38% of our people being married. So y'all, guess what? That is your test for study guide. So and guess what? That's the only thing you got to do this week. You don't have no other homework. All the homework done for the year. So you got your review you're going to do, and then your test is due by Sunday night. Thursday night, you got your you all got your study guide online for the final, but Thursday night we're going to work our 25 question final. Okay, our final exam review, or whatever we call it.
But Thursday night, we're gonna work on what?
You want now Thursday night, we're going to work on the final exam review.
Okay.
So we're going to work out the 25 questions you're going to see on that final.